Hi viewers, welcome to today's mathematics tutorial. Today we'll be looking at the topic sequence and series. Sequence and series. I'll start with sequence. What is sequence? Sequence is defined as succession of terms in which the terms are related according to a well-defined rule. Sequence is defined as succession of terms in which the terms are related according to a well-defined rule or pattern. Now, in sequence, we said that the nth term of the sequence is the Tn, that is the nth term of a sequence. Alright, now take note. The pattern or rule of a particular sequence might not work out for the next or the second sequence. What do we mean? The formula used in solving a particular sequence is not the formula, or might not be the formula used in solving the second sequence or the third sequence. The entry of the sequence is denoted by this. Now let's just take example. Remember what we said, well-defined rule. Go down to example of 1. Write down the first three terms of a sequence whose nth term is 3 raised to power n minus 2. The question here says, write down the first three terms of a sequence whose nth term is 3 raised to power n minus 2. So according to what we said, here serves as the formula connecting this particular sequence. Like I said initially, that the pattern or rule guiding a particular sequence might not be the same rule guiding the second sequence. Just like example, if I have 2, 3, 4, 5. This is a sequence which is related with plus 1. The first term of the sequence is 2. Plus 1 will give you the second term as 3. Plus 1 will give you the third term as 4. Plus 1 will give you the next term as 5. Now let's take down this particular sequence. For example, if I have 3, 9, 12. Okay. I have 3, 9, 12, 15. In this particular sequence, I have 3 by 3 will give you 9, 3 by 4 will give you 12, 3 by 5 will give you 15. So the difference here is multiple of 3, which increases 3 by 3, 9, 3 by 4, 12, 3 by 5 will give us 15. So the difference here is not constant. A multiple of 3, the multiple of 4, the multiple of 5. So the differences varies. So the rule or pattern guiding the first sequence is not the same rule or pattern guiding the second sequence. Now let's go down to the example we have in 1. Write down the first 3 terms of a sequence whose nth term is 3 raised to power n minus 2. Under solution, what is the nth term of the sequence given to us? The nth term is Tn equal to 3 raised to power n minus 2. And what we're asked to find is the first 3 terms, T1, T2, and T3. So how do we find this sequence? How do we get the T1, the T2, and the T3? It's very simple. Go to T1. Just remember your formula, which is the rule guiding your sequence, which says Tn is equal to 3 index n, or 3 power n, then minus 2. If you're finding the first term, 1 here, we substitute, replacing n in the nth term of the sequence. So T1 here will be 3 raised to power, because you're finding the first term, raised to power 1 minus 2. So T1 will be equal to 3 raised to power 1 is 3. And 3 minus 2 will give us 1. So this serves as my first term of the sequence. What about the second term of the sequence? T2. Using the same approach, just for the second term of the sequence, T2 is equal to 3 raised to power n, which is replaced with 2. So you will substitute. Anywhere you see n for now, we call it 2. So that should be 3 raised to power 2 minus 2. So I have T2 equal to 3 raised to power 2 is 3 times 3. Just put it in parentheses, in brackets. Then minus 2. Then you have T2 is equal to 3 times 3 will give us 9 minus, we bring down your 2. And 9 minus 2 is equal to 7. That's for the second term of the sequence. We have the first term of the sequence, 1. The second term is 2. Then we can equally solve for the third term of the sequence, which is T3. Remember, you're still making use of the same nth term, which is the rule of your sequence. T3 now will be equal to 3 raised to power 3 minus 2. And that will be T3 equal to 3 raised to power 3 means 3 times 3 times 3. Just put in parentheses for the bracket. Then minus 2. You have your T3 equal to 3 times 3. 3 times 3 is 9. 9 times 3 will give us 27 minus 2. 27 minus 2 is 25. Now the question says, write down the first 3 terms. Just mark the word, first 3 terms, which is T1, T2, and T3. So from the answer, we'll just pick the answer, the result for T1, the result for T2, and the final result for T3. Therefore, we said that the first 3 terms is our T1, which is have T1, T2, and T3, and that will give us, just right under it all, just place your equality sign, equal to have your T1 as 1, your T2 as 7, and finally your T3 as 25. So this serves as the first 3 terms of the sequence with this particular formula or pattern, 3 raised to power n minus 2. Alright, that's all about sequence. Then we can equally find the nth term of a sequence, assuming the nth term of a sequence is not given to you. But before that, let's just take one particular example that most students do find difficult in solving. Okay, we go down with the second example, example 2. example 2, which says write down the, let's use 3 times, write down the 3 times, the first 3 times of a sequence whose nth term, first 3 terms of a sequence whose nth term is, we have the nth term to be 2 in brackets 3 raised to power n minus 1, then plus 1 all over 5. Most students do find questions like this difficult, but it's very simple. Using the same procedure, this serves as the nth term of the sequence, which is the given pattern or the formula that you can use to solve the sequence. So that will give us the nth term of the sequence equal to 2 in brackets 3 raised to power n minus 1 plus 1 all over 5 when you close your brackets. So remember what we said initially, that this serves as the formula or the pattern that is guiding the sequence, in which we are finding the 3 terms, the first 3 terms of this particular sequence. So what are we looking for? We are asked to find the T1, the T2, and then the T3. So how do we find the T1, the T2, and T3? Using the first procedure, that anywhere you find your T1, you now substitute the n by 1. So that will give us T1 equal to, we have 2, just bring down the 2 outside the bracket. You now open your brackets. You bring down your 3. Like that, then you consider the n. Which number of terms are you solving? You're finding the first term, which means your n now here becomes 1. Then minus 1 as the power. Then plus 1 as the base, you close your bracket, all over 5. It's all divided by 5. Then your T1 here will be equal to, just bring down your 2 because, why you bring down the 2? It's not divisible by the denominator, so you have to bring it down. And 2 in brackets 3 raised to power 1 minus 1 is 0 plus 1 bracket close all over 5. Then to go down to the next step. From here, T1 equal to 2 in bracket 3 raised to power 0 plus 1 divided by 5. Just bring down your T1 equal to your 2. You bring it down, open your bracket. 3 raised to power 0 will now take us back to the laws of indices. According to 0 law in indices, the 0 law says that anything raised to power 0 is equal to 1. So we obey the law of indices there. Just pick the law there. That's 0 law. 3 raised to power 0 here will be 1 plus 1. You close your bracket all over 5. Then your T1 will be equal to 2 in brackets. 1 plus 1 will give you 2 in the brackets, all divided by 5. Then equal to, you can open your bracket here by multiplication, because the bracket means times. So 2 times 2 inside the bracket. Remember that this particular 2 is from the pattern. So the 2 times 2 here will give us 4 over 5. At 4 over 5, nothing can divide here. This is 4 over 5, which is a proper fraction. So you leave your answer as proper fraction. Then you go down to the next term, which is the T2. That's all for the first term. Go down to your T2. Your T2 is T2 equal to the same method or approach. Just bring down your formula. 2 outside the bracket. You open your bracket. 3. Just bring it down. Then, which number of terms are you solving for? Now, we are solving for the second term, which is 2. You take it as your power, minus 1 as the power, then plus 1. You close your bracket, all over 5. It's all divided by 5. Then you still bring down your T2. Your T2 is equal to, bring down 2, which is outside the bracket. 2, open your bracket. You have 3. Raised to power. You solve or simplify that of the power. 2 minus 1 will give us 1 plus 1. Close the bracket, all over 5. Then bring down your T2. Bring down your 2 outside the bracket. 3 raised to power 1. Anything raised to power 1 still remains the same. So 3 raised to power 1 will still give us 3 plus 1, bracket close, all over 5. Then T2 will be equal to, you bring down your 2, open your bracket. 3 plus 3 is 4 divided by 5 equal to 2 times 4. Remember what I said initially, that bracket simply means times. So 2 times 4 will give you 8 all over. You have 5 down. So the fraction we have here is improper fraction. You have to change it to mixed fraction. You divide. Say 5 divided itself will give you 1. Then 8 divided by 5, there is 1, remainder 3 all over 5. So this serves as the second term of the sequence, while here is the first term of the sequence. But the question says, find the first 3 terms. We are through the first, second, then remaining the third term of the sequence. Then we have to go over to the rest. Okay, for the third term, still remember the nth term of the sequence to be 2 in bracket 3 raised to power n minus 1. Then plus 1, bracket close, divided by 5 is still the formula we are using. There's a pattern. It haven't changed. Then the T3 of the sequence will be equal to, bring down your 2 outside the bracket, all over, 2, then open your bracket, 3 raised to power n, number of terms. Which number of terms are you solving? 3 minus 1 plus 1, close your bracket, all over 5. Then you bring down your T3 will be 2, just bring it down, open your bracket as the numerator. Then 3 raised to power, simplify the powers or the index. 3 minus 1 will give us 2 plus 1. You close the brackets, all over 5. Excuse me. Then T4, so T3, just bring down your T3 equal to 2 in bracket. 3 raised to power 2 is 3 times 3 is 3 multiplying itself into 2. 3 times 3 will give us 9 plus 1. You close the bracket, all over 5. Have your T3 equal to 2 in bracket. 9 plus 1 give us 10 all over 5. So here we have 2 times 10 by opening the bracket to give you 20 all over 5. 5 cancel itself. 1. 20 divided by 5 give us what? 4. So definitely what we have here is we have T1, T2, and T3 to be equal to, T1 is 4 over 5. over 5. Then T2 is 1 whole number 3 over 5. And our T3 is 4. So this serves as the first term, the second term, and the third term of the sequence. That's all about sequence. Okay, definitely today I will introduce the formula for finding the nth term of the sequence, while in our next class we continue from there. Okay, the nth term of the sequence nth term of a sequence. The nth term of a sequence are 2 in number. The nth term of a sequence can be solved. You get it whenever the terms of a particular sequence have just one common difference. And the nth term of a sequence, whenever the terms have separate differences. What do I mean by separate differences? If the difference between the first and the second term is not the same with the difference between the fourth and the fifth term, we say that the differences are not common. But if the difference between the first term and the second term is the same with the difference between the fourth term and the fifth term, we say that the nth term, the sequence have a common difference. Now, what do I mean by that? If I have a sequence in the form 1, 2, 3, 4, 5. From this particular sequence, what is the common difference? Here, 1 serves as my T1. Okay, I have my T1, my T2, T3, T4, T5. Now, what is my difference? D. Difference here is D. How do you get a difference? By subtracting the smaller term from the bigger term. The successive smaller term from the successive bigger term. I have T2 minus T1. What is my T2? 2 minus. What is my T1? 1. 2 minus 1 will give you 1. Then we have another difference. Let's check the T5 minus T4. Here my T5 is 5, while my T4 is 4. Then 5 minus 4 will still give me 1. So from this very expression, you discover that the difference between this first and the second term and the difference between the fifth and the fourth term are the same. That is 1, 1, 1. For a situation whereby I have a sequence in the form 1, 2, 5, 7. Having this particular sequence, while here I serve as my T1, my T2, T3, and my T4. From this approach, we discover that the differences are not the same. Let's just watch out. Let's solve and dictate. Let's look for D. The difference as usual. How do you get the difference? You subtract T2 minus T1. What is our T2? T2 is 2 minus our T1 is 1. So what is the difference? 2 minus 1 will give you 1. Now let's take the next difference, D, using the higher T4 minus T3. T4 here is 7 minus T3 is 5, equal to 7 minus 5 will give you 2. So if you write the difference, the first difference is 1, while the second difference is 2. So this sequence is different. The separate sequence from the first sequence. So the first sequence has a common difference, while the second sequence, their differences are not the same. So in our next class, we are going to look into how to find the sequence or the nth term of a sequence with common difference and without common difference. Thank you for watching. See you next time.